This video is about a simple high-frequency IGBT driver you can build at home. You will learn how to create a high-frequency PWM LED dimmer using Arduino and the fast PWM library. In this project, we demonstrate how to achieve a smooth light fading effect with a frequency of 12 kHz for precise and silent operation. Perfect for light dimming, motor control, and other applications requiring high-speed PWM. This driver uses a signal from an Arduino to control an IGBT. It boosts the signal to 15 volt with high current, making the IGBT work efficiently at high speeds. The driver needs 15 volt to operate and is designed to be safe. If the Arduino signal is lost, it automatically turns off the IGBT to prevent damage. This project is beginner-friendly and a great way to explore advanced pulse width modulation control with Arduino. Download the fast PWM library from the link below and follow the step-by-step instructions. This circuit is ideal for high-speed switching of IGBTs and applications such as motor drives, inverters, and SMPS circuits. It ensures efficient and safe operation in high-frequency environments. The project is now nearly complete. Simply download the Arduino code from the provided link and upload it to your Arduino board using the Arduino IDE. Once uploaded, connect the Arduino to the IGBT driver circuit you just created, ensuring the PWM output pin is linked to the driver's input. Finally, attach a bulb as the load, connecting it appropriately with the IGBT. Once powered on, your setup will be ready for testing and demonstration. Here on the multimeter, you can observe the frequency at which the project is operating. The Arduino sends a PWM signal to the IGBT driver, which controls the IGBT to adjust the bulb's brightness. For safety, if the Arduino signal is disconnected, the fail-safe feature ensures the IGBT turns off, stopping the bulb to prevent damage. This project demonstrates how to build a simple yet efficient high-frequency IGBT driver using minimal components. With its ability to safely and effectively drive IGBTs at high speeds, it is perfect for applications like motor drives, inverters, and other high-frequency operations. The added fail-safe feature ensures reliable performance by protecting the circuit in case of input signal loss. If you enjoyed this project and found it helpful, don't forget to like, share, and subscribe to our channel Hobby Electro Lab for more exciting DIY electronics projects and tutorials. Join us on our journey of exploring the world of electronics and innovation.